Thank you, Mel, and thank you, Water Sensitive USA, and thanks, team. So I'm Harsha, and I'm research manager with Space Down Under. So I joined David Laurie after my PhD. So this is my case study site and my research site as well. So I spent my 5 years on this street. So on this street, everybody knows who is Harsha. Yeah, I did a lot of infiltration testing, 45-degree, 1 degree. I experienced everything on this site. Wonderful site, wonderful people, and thank you, Mitchum. So this site is a residential area at Ainsbury, Mitchum in South Australia. So where we have total 28 inlets, and I just draw those to see the subcatchment from where we just collected those lot of sediments out of that. Otherwise, it is just the whole residential street. Some catchment characteristics. So the total area of that site is 2.7 hectare, having 1 to 1.4% of slope. So we calculated a lot of pervious and impervious area and semi-impervious area that is connected to our TreeNet inlet using QGIS software. So as you can see here, both impervious and pervious percentage are really very balanced, and yeah, semi-impervious are just the half of those. But can we improve that? No, not possible nowadays. We are increasing that impervious bar and reducing that pervious surfaces every year. So what best we can do to improve our natural water cycle? What we can do to grow more trees, to develop our urban canopy, and what's the best thing we can do for our future generation? So in my study, we had this is the first generation model that we call R300, which is that's the radius 300, and we call it capture zone. So we install total 28 inlets on one residential street that was connected with the leaky well infiltration system. So the deep that is 440 diameter hole with 225 mm diameter of the horizontal pipe, vertical pipe with some few slots, and at the bottom just few holes just to infiltrate some water. So this system actually works as a retention and detention thing. So when water enters through these inlets, pass through this horizontal pipe, it sits there and slowly infiltrate in the surrounding soil with that filter media. So filter media is a very important component of all the infiltration systems. And so for the research purpose, we just trialed 4 different filter media. So one is gravel, 14 mm gravel, water treatment solids. So these are the residuals from Happy Valley reservoirs, and sandy loam and clay. So all equally in 7 pits. So that makes total 28 infiltration pits. I did infiltration testing, water quality, environmental impact assessment, economic analysis, and then finally we thought like for that model that I use is a GABI system, like GABI software, and that requires some information on the waste that generates in this system. And then I just, after 5 years of operation, we just access that site. And so this is very normal. In autumn, you will find a lot of organic material in there, and then it completely goes away with the normal street sweeping. So very normal, very natural. Then we open the back of that plate, and we found 10 to 100 gram of fine sediments sits there after 4 to 5 years of time, which is nothing, and that is just the fine sediments. Won't block the actual infiltration capture zone and not in the pipe as well. So everything was clear. So that was about the capture zone. So what happened with the infiltration zone? This was really interesting when we opened the actual pit, and I found a lot of fine roots entering in the system to get the water, to access the water. How beautiful was that? We found a lot of earthworms in there. They just managing to work together, a lot of insects. So I can say they are doing their work in the well, and that's the something circular economy. We're giving water, trees growing there, trees pumping a lot of water through those systems, and insects, and they got really good environment for their habitat. So when we collect, because we can collect those samples using hydrovac, or you can just use the vacuum pump, but because I want to test how much samples I can collect from each of those well, what sort of characteristics are those, so that's why we just excavate that using these small kitchen utensils like scoops, and collected all sediments, labeled all bags, and after cleaning, it looks like that, very clean. So it is easy to clean, not much problem. Then after this, I just dried all those samples in normal oven and weigh all those samples, take out all the sediment test, like organic material from that samples, and send some samples in the NIT accredited lab, ASL lab. This is something I found in all that in the sediments. So we sent 3 samples. So collected samples from 4 pits, mix it together, make the composite, and then this is just the mean, because all the range, all the sedimentation chemical characteristics is within the range. So I found arsenic, chromium, copper, lead, manganese, nickel, zinc, total petroleum hydrocarbons, which is obvious, and then orthophosphorus pesticide surrogates. So few of those like manganese, zinc, petroleum hydrocarbons are really high, as well as the pesticide one. So because this is, I think, a residential site, a lot of people use herbicides. So we found this compound in the herbicide and insecticide to keep the insects and keep the like unwanted grass away from the actual garden bed. What are the normal sources of these elements, these heavy metals and pollutants? So basically rusty roofs, paints, car brakes, and lot of construction activities happening. So this is all the product of all our activities, but Trinity Inlet capture those using the in the first flush of water. So without end up that with the waterways, we always try and harvest that where it's source. So at source of these sediments. So this is not from the site, but this is the literature review data. So normally from bare ground, you will get 736 milligram of sediments per liter, and then you can see here, like most of them is coming from the construction site, from road and the bare ground. But if you see the grass and roof, it is very less. But with roof, I think we found a lot of PM10 particles, very fine particles on roof, and this is because of the natural cycle. So, our current models, we don't have those R300 or the leaky well in stock. This is something new with the steel plate having 2 slots. Initially, we tried with 1 slot. So, few catchments like Hawthorne catchment, Flinders Avenue and Aldrich Street, they got the old like 1 slotted steel plates there. So, this is also a new design. So, you can see here the pipe arrangement here and the horizontal trench system there. So, that trench is made with the recycled wheelie bins. So, we are trying to generate some circular economy here. So, our waste end up there and we are using that as space media as a filter material, but you can use anything. So, these Trinet inlet systems. So, this is the photo from Port Adelaide and Enfield Council. We just install 6 systems there. So, we are trying different product on that site as well. So, you can see 2 slotted R750 and this is our new model. So, do not worry about these extra pipes. This is just to collect some water quality samples, outflow samples from the system. So, you can see this is a small pipe there. So, we install 1 pipe, just a slotted pipe there to collect some inflow samples before it is entering in the system, and then these 2 pipes, one for the ICT soil sampler and one for, so we developed that water collector underneath. So, we install that water collector underneath with the funnel and then we can see what is the water quality going in and then going out. So, these are my some current projects. So, this is project at with the Ligatus Group Council. So, 3 councils come forward and they want to try these systems. So, one council is the so this is the 2 wells catchment and Drew Street. So, the total area is 3.85 hectare and we got 5 R750 and 5 infiltration trench, the same with the recycled one. The installation happened in July and this is really good tree species that I missed on my site. So, I got the same tree species on my site, but I want to see how it grow with the additional supply of water. So, I got the chance to collect some data for golden rain trees and the soil type surrounding soil is sandy loam. This is second site with the Ligatus Group Council. We have here total same 5 inlets with 5 infiltration pit and different tree species Takaru, and we got the medium clay there and see how those will go by the time. This is our third site which is Wallaroo. So, 3.85 hectare double slotted, again same structure there, and then we install that in the June, July, and again we are trying some pine trees there and the soil type is sandy one. So, we are going to install some water level loggers. It is ready and I think Tim and I are going there next week on Tuesday to install that. Hopefully, I will be back with some good data and see how those goes. This is another project we are working with the Hydro Rock, collaborative project with the Hydro Rock, UniSA, ourselves and Port Adelaide and Enfield Council. So, we got 3 systems. So, one system with the Space Down Under, Hydro Rock, Space Down Under. So, we got total 6 systems there. So, 3 of each, and you can see those extra pipings here and this extra for just to get some more data from those sites. Oops. Okay. This is also a current project. Tim and David started collecting a lot of data from Aldridge Terrace, and site is at the city of West Orange. So we got 25 trees with inlets and 26 trees with the drip irrigation, and then 4 trees with control irrigation. So we always go there on site 3 times in a year and measure the tree height and diameter and see how those are doing. They're doing really good, and the difference is just here. This is with inlet. I took this photograph on 26th of February 2020, and at the same time this is without any water system, no drip irrigation, so with just the control. So council just watered that based on their water type. It means trees really need water in urban environment to grow and flourish. Summary. So this is Trinity inlets are the public WSUD infrastructure. It harvests stormwater directly from the street trees and use that for the street trees growth, and trees are happy, really. So they are very cost effective. These systems collects a lot of pollutants and heavy metals at the sediment source. So where we get that sediments, it actually sits there. So as Tim told us, the sediments settle here. If no sweeping, sediment settles there, it works as a filter, and same thing happened in the infiltration pit. Those sediments works as a filter. So if in second event, if water enters in the system, lot of those heavy metals stick with the other particles and only filtered water enter in the system. Thank you so much, Mitchum and our other stakeholders and HydroRock Products.
Thank you, Harsha, and thank you for all the research, because we often get asked for the evidence at Water Sensitive SA, and it's going to be great to be able to tap into all of that, and we'll make sure we link through on our website to the evidence that UniSA and Harsha and TreeNet are pulling together, because that's the bit, I guess, when we're trying to build the business cases to management. It's this type of evidence that everyone is asking for. So we really appreciate that you're doing the hard yards, basically. Does anyone have any particular questions for Harsha now, before we move on? Yes, Ryan?
How do they compare to like the waste soil classifications in terms of if you ever need to go in and dispose of that soil later, like did you do any tests on the surrounding soil to see whether that was, I suppose, permeating, contaminating that soil, which might be, I suppose, a legacy issue?
Yeah. So this morning I was thinking about this question. Thanks for asking this question. So maybe it's good to go back. And so with these elements, with these heavy metals, if it is entering in the system, you excavate that, and I checked the limits. It is within the limits. It's not exceeding the limits. But if you think it is industrial site or the highways where you get a lot of more than this, then certainly you need to follow the guidelines by EPA. I didn't find any updated guidelines, sorry, but I checked everything based on the old guideline, and I found this is within the limit. This is little bit high, but I think it is just the residential area, people trying to use lot of herbicides and pesticides, and that's why it is really high, maybe. Yeah. So
I think that's a good question, because I had a similar one here. I think it'd be great even if you could show us how far off the maximum limit when you present your data, how far off it is that maximum, because I think that's going to be useful information to local government. Yeah.
Yes, I do have that information, but I got that this morning, so I wasn't able to put that in.
No worries.
Sorry.
And also your the tree trial at the end, comparing the different passive infiltration, drip irrigation. Where is that trial?
That's Aldridge Terrace in city of West Torrens.
City of West Torrens. Okay, oh yeah, great, excellent.
Yeah.
Okay,
I just sent those photographs to Alan Martin for
great, excellent.
the decision.
I've got a
making.
question, Sam, up the back.
By doing this, we're taking heavy metals so we're making them an asset owner's problem in quotation marks by putting them into an asset, whereas otherwise they would be externalities. They simply would have had an impact on the environment that was nobody's problem. So
Yeah.
Don't think of it as contamination. Think of it as doing a public good and obviating nobody's problem, environmental damage. Good point.
And also, I forgot one thing. So we can capture those sediments and avoid entering in this system. We can capture everything here by putting one instrument. David is making that, and we are trialing that on a couple of sites. So anyone wants to try that, we are here to help you.
So a bit like a first flush device or something like that?
Yes,
Okay.
so we will capture some here, then we have one sedimentation trap here, and then only filtered water entered in the system, and then we can take out that bit after 1 month, 2 months, and see what type of sediments settled in that pipe. So it's in place, so we can try that. Yep.